start, right?
Yes, please. The floor is yours.
Okay. Okay, so guys, before we get started for today, so I want us to like 3 people or 5 people quickly in 1 minute. You can share with me what you learned in the last class. Like I want like okay, I learned this. Starknet is this. I learned StarkX is this. Starkware is this. Validity rollup is this. ZK Stacks is this. So those are the kinds of like okay. So love it. I want to hear from you first. I love it. Are you raising your hand to speak? Like okay. Mubarak, Afolabi Mubarak. Please you can unmute.
Yeah, good evening.
Mm,
We're able to like cover up on what Starknet is all about, and we know that Starknet is a permissionless layer 2 scaling for Ethereum, and we also like
right.
this analysis between Starkware, Starknet, and StarkX. So we were able to know that Starkware is the company behind the Starknet, and some other
Mhm.
too. And we also did some things on validity rollup. So we know that validity rollup work by executing transaction off-chain bundling, off-chain bundling that link a single proof and then submitting the proof to the Ethereum uh, mainnet. So we know that Starknet is unique with the use of validity rollup.
Thank you. That's really beautiful and awesome. And that means you really followed. Okay, so innocent. Please you can go quickly. We have a lot to cover today. If innocent is not there, Chris, please go ahead and share with us what you learned.
Okay. I don't know if you guys can hear me.
Yes, we can hear you.
Okay. In addition to what the first person said, he said Starknet is built for Ethereum, but just a little correction is Starknet is built on Ethereum, not for Ethereum. I guess if I'm right.
Yeah,
Yes.
yeah, you got that right. Thank you for that
Yeah,
correction,
yeah,
Chris.
yeah.
Okay, Richard.
Sorry about that. I said it is built like is a layer 2 scaling solution for Ethereum. I didn't say it is built for Ethereum.
Yeah, thank you. Richard, if you're not there, Christian Ephraim, please you can share what you learned. I don't want us to wait more time, just one more person. Innocent. Can you guys hear me? Or is it like these people? Okay.
I can you hear me. Good evening.
Good evening.
All right. So to add to what he said, basically I said everything. So basically how it works, I will talk about how it works. So um the Starknet transaction are collected off chain. I think he has already talked about it. And the package along with the proof is submitted to Ethereum. The verification how it's done, Ethereum verify the proof, effectively validating all the transaction at the same time. So basically that is how the Starknet protocol also works. So
Okay, awesome. Thank you everyone for the awesome, beautiful contributions, and it really shows that you guys followed through. Yeah. So if you didn't join the last class, I just hope that you went through the recording. So we're going to be starting today's class now. Let me share my screen. Let me know if you can see my screen. Okay. Okay. All right. So we'll be kickstarting from, we're supposed to be starting from Starknet architecture, but I realized that we need to do a little of introduction to Cairo itself and why Cairo before we get into Starknet architecture. So like the way I arranged it is the way that, okay, so you want to ask a question, or please, if your mic is unmuted, please mute your mic so we can have a smooth ride. Thank you. Okay, so we're going to be looking into Cairo. Why Cairo? We're going to be looking at smart wallets. I'm also going to be explaining account abstraction in the process, Starknet architecture, transaction lifecycle on Starknet, transaction types, finality and consensus on Starknet, Cairo syntax overview and the program structure, and then setting up all the development environment to kickstart writing your Cairo programs or your Starknet contract. Okay, so Cairo, what is Cairo? What is Cairo? What is Cairo? Okay, so before I talk about why Cairo, so I'm going to use a simple example. So before, just a little spoiler alert. So there might be some things, some concepts I'm talking about that you don't understand. Just note those concepts down. I think the people that will be able to flow very well with me are either people that already know Solidity, they are well versed with blockchain development, stuff like that. So, but if you do not get a concept, just write it down. And if I can, I will do justice to answer your question, explain as I can. If not, you should go after this class to research on your own, right? Okay, so Cairo. What is Cairo? Just like any programming language like Solidity, Cairo is a provable programming language, right? It's a provable programming language. Let me explain this. Okay, let's say, for instance, now we have a bank, or you have a bank where, or maybe I built a bank. Sarah built a bank where people can um, they can rent deposit boxes to keep their valuables, like their jewelries, important documents, just important things, their valuables. And then a key is assigned to each of these deposit boxes, right? That only the person that has the access to the key can unlock that box. Now, there's a little issue with that. A little issue arises in that, what if the key gets stolen, or there's a duplicate of the key is done, or somehow the key is lost or something, and someone else gets hold of the key and then opens your deposit box to get out your valuables. Now, what can be done? So to solve this, my bank, I install a new digital lock on of every safe deposit box in the bank. Hope you guys are following me. Please, if there's any distraction around you for the next 2 hours, just try and focus on this thing. Please, just try and focus on this class, right? Okay, so now to solve the problem of if key is stolen, because anybody can get access to your key and then steal your property. And yeah, so To solve this, I install a digital lock on every save box in the bank. So these locks don't just rely on the key anymore. So instead, whenever someone that has the digital box, I mean the deposit box, wants to open their box, they have to enter a unique code, right, with using their key. So they are going to be using the code, the unique code that they only know of, and the key, the physical key that they have to unlock this box. So now this code acts as a verification proof that yes, the person opening this is the owner. The code that's it's something that cannot be guessed or duplicated. If you like, go and use 1, 2, 3, 4 that can be guessed. But then, like, the idea is something that a code, a unique code that can't be guessed. Right now, the lock checks the code instantly before it opens the box, ensuring that only the person with the correct proof, that means only the person with the correct code, can access the box, right? So now, with this, people can feel safe knowing that if anyone got their key, they wouldn't be able to access the box without a correct code, right? Now, connecting it to Cairo, the safe box represents smart contracts. The safe deposit box that we're talking about here, where people keep their valuables, their important valuables, represents smart contracts or important data on the blockchain. The key combined with the digital code are the command proofs used in blockchain. So Cairo, which is now a provable programming language, acts like the bank digital lock with verification codes. So when you write a smart contract in Cairo, the language, it doesn't just execute command based on trust alone, right? Instead, Cairo generates a mathematical proof that is, in the sense of the digital box, it's a digital code that verifies the correctness of the program's execution. So this proof is like a seal of authenticity that ensures the program behave exactly as intended. I don't know if you're following. So Cairo is a provable programming language. It just means that the program can is a program with computation can be proven without you having to re-execute the program to compute results. So this proves attest to the integrity of the computation. So I don't know if you guys are following. Are you guys like getting it?
I think we stopped seeing your screen. Can you check?
Okay. Wow.
Meanwhile, if you are following, please type "ride on" in the comment section. Probably we'll be using that method to be sure they are following and not just the reaction, because not everybody might react. If you are following, type "ride on" in the call messages. Perfect.
Okay, awesome. Can you see my
Yes,
screen
I
now?
can. Somebody said it.
Okay. So what you're lost? Favor, why are you lost? How are you lost? Please quickly tell me so we can get on it. How? It's just as simple as it is. Wow. Mhm. Okay, it's just as simple as it is. You don't understand. Cairo is a provable programming language. Unlike Solidity, if you are you familiar with Solidity, Favor? Wow. Okay, Solidity is the language. So what I mean by provable is you being able to prove. So see the example that I used for the digital for the deposit boxes in the bank, right? You have a deposit box in the bank which contains your valuable, right? You have a key and you have a unique code that you can use to unlock this box. Now, comparing this scenario to Cairo, this unique code is what we use, what is used to compare to as the verification proof, right? Is a verification proof that you are the owner of this deposit box. Because, you know, if it's only the key that we're using, anybody can access your key. Your key can get stolen, right? Now, with the code, the unique code, together with the key that you have, you can prove that, thank you, something like that, you get, you're the owner of this deposit box. Now, coming to this programming sense now, Cairo is a provable programming language. It's not like any other, it's a special programming language. It's not like any other programming language that you see out there. Rust is not a provable programming language. Cairo is a provable programming language in the sense that it can prove the computation of its program without you having to re-execute it, right, to compare results. So what makes this possible is the verification proofs that is being generated under the hood. So do you understand it now? Please let me be sure that you understand this. Beautiful. Okay. So now, why Cairo? Why Cairo? Why use Cairo? From the explanation that I just made, why should you use Cairo? Because one, Cairo enables. Yes. Please, what are you saying? I can't hear you, please. Please, can you drop a message if you can't talk? Because I really don't want us to waste time on this. I can't hear you well. I can't hear you well. You can just drop your question in the call message box. Okay, so why Cairo? Because one, Cairo enables verifiable computation. Every step of every computation you make is verifiable, like automatically. Cairo is built, its architecture was built like that, right? That every step of your computation is verifiable. I think it would be more clear along the line. So why do we have so much ends, lyrics? Innocent. What's this is just the first line. Okay, Innocent, please speak up. Because we do not have much time, I tell you. Uchena, or you guys are just raising up your hands for nothing.
Let's continue, ma.
If you have a question and you raise your hand, please speak up. If not, all the rest of you should drop your hands, or I'll drop it for you.
Okay. Now, I mentioned that Cairo enables verifiable computation, right? Now, it's proof. This attests to I mean, this proofs attest to the integrity of the computation that you write. It verifies without you having to re-execute the program to compare results. So what I mean by re-execute to compare results is that this actually happens when you deploy your smart contract, right? It happens when you deploy your smart contract and the sequencer wants to confirm if the program is correct, right? So all of these things happen under the hood, being like the program being able, its architecture is just built like that, without having without you having to re-execute the program itself. Now, this Cairo is a powerful programming language, and it's a flexible programming language than OOP languages like JavaScript and Solidity, because it allows for creation of more complex programs that Solidity cannot do. I mean, Solidity you can't program in Solidity, right? And then one thing you should know is that Cairo can be used outside of Starknet. It's not only used to create smart contracts on Starknet. You can create any program with Cairo. An example of Cairo used outside of Starknet is Zero Sync. It's a project that's created to be able to prove Bitcoin UTXO. Let me not just go into it, but you can check out Zero Sync after now. It's an example of Cairo used outside of Starknet. So another reason why Cairo is important is because it prevents cheating and malfunctioning, and then it keeps a supercomputer honest. A supercomputer in this sense is the sequencer. We are going to get into the detail of sequencer when we get to Starknet architecture. Okay, so I already explained the part of the being a verifiable computation, right? Cairo's syntax is similar to Rust. You should note that while Cairo's syntax is similar to Rust, they are not exactly the same, right? They are not exactly the same. They are different. But Cairo's syntax was actually inspired by Rust. Cairo's compiler, Cairo compiles to the Cairo VM. Rust doesn't compile to Cairo VM. Rust compiles to the traditional CPU architecture of your computer. So they compile to two different things. Now, your Cairo program compiles to Sierra. Now, one thing you should understand is that just please open your mind. Don't be distracted. Before the introduction of Cairo 1, there used to be Cairo 0. That was at around 2022, 2021, around that time. No, 2022, should be 2022. Yes. Cairo 0. So Cairo 0 was a low-level language at that time, and its syntax at that time was inspired by Python, right? But it was kind of difficult to learn, and it was really developer friendly. Now, the issue with Cairo 0 at that time was that there was no Sierra. Now, Sierra not being present at Cairo 0 introduced a problem in the sense that once the Cairo smart contract is being compiled to CASM and deployed, right? Failed transactions aren't included in blocks. That was the design as at that time. So because of that, it created a loophole where users could spam the network with failed transaction, knowing fully well that, once a transaction is not included in a block, you're not going to be paying gas fees for that transaction. So because of that, sequencer don't get paid gas fees for failed transaction. So there was a problem. There was the issue in the network, whereby sequencer can choose to they can choose the transaction they want to execute and whatnot. So to solve this, Starknet implemented a system like that of the Ethereum, system, whereby even failed transactions get included in block. And once a failed transaction gets included in block, the sequencer is going to still get paid gas fees, and then the person whose transaction was failed, was reverted, would pay gas fees for that particular transaction, right? So that was possible through the introduction of Sierra. Now, smart contracts, Cairo smart contract gets compared that to Sierra. Sierra is the full meaning of Sierra is safe intermediate representation. So safe intermediate representation. Now, once the Cairo smart contract gets compiled down to Sierra, the sequencer compiles Sierra to safe CASM. So the sequencer will be the one to compile the Sierra down to safe CASM. You don't have any business in this. The sequencer is the one handling this, and CASM is full meaning of Cairo assembly. Now, after the sequencer compiles this to safe CASM, it generates a validity proof, which is now being sent to Ethereum, and then if failed, and all of that. So now failed transaction, okay, I already mentioned that. So sequencer are now always compensated. No more DOS attack vector as in Cairo 0. Cairo 0 had DOS attack, right, where users were spamming the network with failed transactions. So, but then right now it's no longer like that. So more features of Cairo. Cairo runs on top of the Cairo VM. Cairo's syntax is inspired by Rust with similar ownership model. If you're familiar with Rust, you know what I'm talking about when it comes to onyship. But even if you're not familiar with Rust, ownership is going to be explained to you in the coming days. Starknet, Cairo, like I mentioned, can be used outside of Rust. And one beautiful thing, you don't need to worry yourself about this whole mathematics around Cairo, you don't need to know ZK before you can take advantage of Cairo. You just have to focus on the language, learn the language, and build cool dApps with it, right? Okay, so before I go to the next session, is there any question at this point? Okay, no question. Thank you. So moving to smart wallet. VM is virtual machine. Moving to smart wallet. What is a smart wallet? A smart wallet is a wallet that allows you to sign transactions with Touch ID or Face ID. Execute multiple transactions in execute multiple operations. I'm always having transaction in my head. Execute multiple operations in a single transaction. One beautiful thing about Starknet is that it gives you account abstraction. Like every wallet on Starknet, Ardent Wallet, Bravos, they are all smart wallets. I'm going to get into account abstraction in a bit, right? So, but then what you need to know is that every wallet on Starknet is a smart wallet. There are no EOAs. What EOA means is externally owned account. On Ethereum, there are two types of accounts. We have smart smart contract address, right, and externally owned address. Smart contract address is the address that is being generated when you deploy your smart contract. While EOA, externally owned address, is the address you have in your wallet, a user address, the address you have in your wallet, example, MetaMask. That is an EOA. But there's nothing like that in Starknet, right? There's no EOA. Instead, it is built using smart wallet is built using account abstraction. The providers we have are Agents and Bravos. I'm going to be explaining, just calm down, I'm going to be explaining account abstraction in a while. So we have complex interactions. Sometimes an action requires multiple steps, users, operation. I don't know if anyone has tried to interact with maybe you want to swap a token and then you use Uniswap as an example. You use Uniswap and before you are able to get your token to sign a lot of transactions. It's not just one transaction that you sign. You sign approve token this to this this that. I don't know if anyone understand what I'm trying to say. Okay, thank you. So, and if you don't understand, what I'm trying to say is when you want to swap like tokens, if you want to trade your tokens, it's not a single transaction, right? You have to perform multiple transactions. So the problem with this is that, when you're performing, think about it. When you're performing the multiple transaction, the first transaction that you perform, please listen carefully. The first transaction you perform, you click the transaction, you sign the transaction. Do you know that someone else on the network is trying to perform another transactions too? Right now, the person transaction, that first transaction that you signed is being sent to the Mempool, which is being checked by the validator before it's being added to a block. Right now, another person on the network is also signing the transaction. Right now, that person transaction also is sent to the Mempool, same does, and then it's been added to block. Now we have if you're going to be signing, let's say, to only trade a token on Uniswap, you're required to sign, let's say, 3 transactions, for example. No, let's say 2 transactions, because we have 2 this thing here. So step 1, step 2. Let's say you've now signed the first transaction. The thing about Ethereum is that this transaction, right? Transactions on Ethereum, they go as they are ordered. Like if someone is signing transaction here, it goes to the block. It won't wait for you to sign the other transaction for it to put in the same block. It doesn't happen like that. So now you will not have both of those transactions that you are expected to sign to trade a token in the same block. What happened is that the first transaction can be in a block, right? Followed by the other person that's trying to sign the transaction on the network, and then it could be followed by your second approval of the transaction that you are trying to sign. Or you could have that your first transaction is in a block with other people's transaction on the network, or other people's transaction, then your second transaction is in a separate block entirely. Now, there is a problem with this. in the sense that the MEV is maximal extractable value. They can, sorry, what is happening with my Cairo? 1 minute, please. Okay, it's here. Now, this could be exploitable by MEVs. So I don't know, I know some crypto persons here should know what MEVs are. So they are maximal extractable value. So it refers to as the profit that extracted by my validators or bots by reordering or inserting transaction in a block. So some validators could choose to reorder transactions in block. That is what happened in so reordering of transaction is what happens in could happen in chains that can't they do not allow multi-core. This is actually a multi-core, actually. So so the way MEVs these validators actually kind of take advantage of the system is either the front run transaction, right? Blockchain developers here should know what, not just blockchain, crypto people should know what front running means, sandwich attack. So for people that do not know, front running is when a validator or a bot sees a pending transaction in the mempool. Mempool is a place where unconfirmed transactions wait in to be included in a block. So you know, once when you sign your transaction, it's not immediately that it's being picked up by validators, right, to be included in a block. It takes a while because of it could be because of many transactions in the system as at that time. Now, and then the validator could place their transaction ahead of your transaction. Please, is there a way to mute everybody? Because this could be distracting. Yeah.
Let me check.
So, like I was saying, a validator or a bot could take advantage of unconfirmed transaction that are waiting in the mempool to be included in a block, right? And then they could place their transaction ahead of it to benefit from the market reaction to the original transactions. A lot of things can happen. A lot of things could maybe which example is coming to my head? Okay, for example, let's say there's a large trade that is about to happen on a decentralized exchange, on Uniswap, for example. Now, a front runner can place their own buy order first, anticipating that the price will rise. So once the price increases due to the original large trade, the front runner sells at a profit, leaving the original trader with a worse price. So this is like one of the ways front runners could cheat the system, right? Sandwich attack is also similar to this. So that one involves both front running. The front run is when you came first, right? Your transaction came first, but somehow they reordered your transaction and now they are first. Your transaction is at the back. Now we have sandwich attack is it involves both front running and back running. So a bot could see a pending trade, right? Place a buy order just before it, that's front running, and a sell order immediately after it, that's back running, right? So the trader in the middle gets sandwiched. You know how sandwich is now? The one in the middle now, that's the trader in the middle gets sandwiched and ends up buying a worse price, while the bot profits from both front and back positions. So this is actually really common with decentralized exchange, where price slippage and large orders can be exploited. So this is exactly what like MEVs. This is how MEVs can cheat the system with single transaction instead of like multi. If transaction that you want to execute requires multi-core, right? The system can be cheated. So now multi-core on Starknet, multiple users user operations can be done in a single transaction. Now, when you want to execute a transaction, you can go on Ekubo, for example, is a decentralized exchange on Starknet. Once you sign your transaction once, everything happens. So that is one of like the benefit I was talking about. This is actually possible through account abstraction. Account abstraction is the combination of having a smart contract as a wallet. So now, account abstraction is what makes multi-core possible on Starknet, right? It can perform like logics that you can think of as a developer. So now, with multi-core on Starknet, you can have your transaction steps, all the transaction steps that you are supposed to execute in a block. So this doesn't happen now. You are free from exploits. So that's one benefit on Starknet, multi-cores. Now, account abstraction. Now, account abstraction. Account abstraction, like I mentioned, how do I explain it so you understand? Okay, so account abstraction is can you guys see my screen? Let me be sure.
Yes, there are some questions for you in the chat.
Okay.
I think it was when you were talking about validator.
Okay, validators are on, they are the ones that verify your transaction on Ethereum on EVM compatible chains, right? I was just using, a lot of people use bots, right? I don't use bots, but I was just using that as an example. But as a validator, you have your computer is one of the ones like confirming transactions on the blockchain, right? It doesn't happen. I don't think it does happen anymore, though. But yeah, validators are the ones responsible for confirming transactions on the blockchain. Yes, so the, does it have anything to do with the speed of transaction? Yes, it does. Now, if your transaction is being front run, definitely the transactions that goes first before your transaction will get executed first before your transaction. So it's the speed. It has something to do with the speed, yes. And then something that happened on the Ethereum network, that you can increase your gas fees for your transaction to be sharply executed. It doesn't happen on Starknet. If you like, pay pay how many stack, you won't. It doesn't happen on Starknet. So that's one of like the great reasons why you should. Okay. So is your question answered now? Is it David? Good. Thank you. Okay. Okay. So um account abstraction. So account abstraction on Starknet, right? It refers to a system, right, where smart contracts can act as wallets. Smart contract can act as wallet. Remember, I mentioned that all wallets on Starknet are smart accounts. If you have an Ardent wallet here or Bravos wallet, they are smart accounts. Now, compared to the traditional wallets that we have, MetaMask as an example, like their EOAs. So it's just like it's just a wallet to that holds your asset, that holds your tokens, your NFTs, and sign transactions. That's all that it does, right? So it's limited in what it can do, actually. So that's where account abstraction shines, right? Account abstraction. So account abstraction is also on Ethereum. That's ERC 4337. Let me just type it here. So ERC 4337. You can check it out after now. Yeah. So account abstraction. So instead of a wallet to be just um, a simple um, one where it can just hold assets, it can just hold NFT, sign transaction, do transfers, right? It becomes a smart wallet. It's smart. This smart wallet is actually like a smart contract itself. It can be programmed to do much more. Like it can be programmed to do a multi-signature, like a lot actually. Now, one of the features of smart wallet is multi-sig, right? Also, the recovery method is different. You know, the recovery method of a regular wallet like MetaMask or Trust wallet is either you copy your seed phrase or you back it up on your Google Drive. Yes. So it's either of the two. And then if you lost your seed phrase or your private key, or something happens to your phone, it has happened to me like that before, that I stored my private key on my phone and then one day my phone stopped working. It literally stopped working as if village people were after it. That was the end. But with smart accounts, there are a lot of recovery options. You have a lot of recovery options, right? You don't even need, there's no need for seed phrase. Instead, I can't remember storing seed phrase, but when we open when we install the Ardent wallet, you see. Now, do we understand as regards the explanation of account abstraction, or you want me to go deeper?
If you understand, please type I understand in the chat. Let's be interactive. Don't just keep quiet. If you understand, type I understand. If you don't, please type recap, please, so that you should recap. If you keep quiet,
Okay.
nobody knows what you know or what you don't know.
Okay. I understand. A lot of people go understand. Okay. So, okay, let me just recap. So, account abstraction, right? You know your normal crypto wallet, like MetaMask or Trust Wallet. The only thing that it can do for you is to keep your tokens, both your fungible tokens and non-fungible tokens, right? Sign transactions, right? That is what your wallet can do. And the way you recover, you go on, the way you recover your private key on MetaMask or any other wallet that you are using, or any other crypto wallets that doesn't support account abstraction, is that you either copy your private key, right, or you copy the master, which is the seed phrase, keep it somewhere safe, or you do Google, is it Google Drive? Yeah, Google Drive recovery. Yes. So, but you know, there is an issue with that, in the sense that if you lost where you kept your private key, for example, right? Just like I was explaining that safe, right? If it get lost or it gets stolen, there's no way for you to get your funds back. There is no way, except maybe there are multiple places that you kept your private key for you to be able to recover them back, or except you recover it using the Google Drive. But if all of this, it's possible that you can, this is something that has actually happened to me before, that my phone got spoiled and I was unable to fix the phone. Like, I'm dead serious. So now with Starknet that supports smart wallets, it doesn't happen like that. Smart wallets are wallets that have smart contracts. They are smart contracts in nature. They do not just hold your assets, right? So the way account abstraction, it actually changes how we manage our crypto accounts. It's where you know, I don't know if you're getting me, if you're actually following, right? Okay, so you know, account abstraction, okay, thank you. Account abstraction moves away from the current simple model that we have, that crypto has, right? Where a mistake could cost you everything, to a place where accounts can be customized to fit your need using smart contracts. You as a developer, you can come and create a I can create a smart contract that um could interact with my agent wallet, right? And then if you're a Solidity developer, or there are a lot of like logic that you can use to control your agent wallet or your Bravos wallet, any wallet on Starknet. There are logics that normal regular crypto wallets cannot do. So that is just it. So for example, a normal crypto wallet doesn't support multi-signature, right? Or does the MetaMask support multi-signature? Agent wallet support multi-signature. So you can have maybe in your family you have, like what Genesis Save does in your family. Maybe you have people that you trust that could help you recover your wallet when it's lost, right? So this whole thing about smart wallets, it's it makes it user friendly for grammars, or I mean all these people do not really understand like the essence of smart wallet or smart something. So it abstracts all those technicalities, right? And then it simplify things. It simplify things for them. So, but you as a developer, right? There are some things that you need to understand that okay, this is what actually happens under the hood. So in essence, account abstractions allows users to tailor their crypto account, right? Their crypto wallet to their specific needs. So it can make it safer or easier for you to use. There are a lot of social recovery that Agent Wallet has, right? It's you can connect it to your email. There are a lot of, and it has a lot of two-factor authentication. So it's not your regular, um, your regular crypto account. So do we get now? Do you understand now before we move on? Thank you too. Okay. So now, account abstraction, like it decouples the coupling of the signer. Signer is the person signing transaction, which is you that is interacting with which is you're initiating the transaction and the account. Now, the signer is the signer is device that signs transaction. It could be your smartphone that has an agent's mobile wallet or Bravo's wallet, or it could be your PC that is signing transaction, but the transaction is coming from you. Now, the signer it's it identifies user with the private key. Yes. So anywhere the transaction sign is coming from, right? Definitely it's the owner, right, that is sending transaction. Now the account, your account, your added account or your Bravos account on Starknet, they are smart contract on Starknet. They hold assets, they hold your assets, they verify signatures, that the signature that you are signing, the authorization that you are making is actually coming from the owner. And also they execute transactions with multi-call. Do we understand? Do we understand? I thought Starknet wallet. So yes, but then under the hood, there's a see, this thing is not going to show that there's a public key somewhere. That's what I was saying, that when you want to authorize a transaction, right? The signer, once you sign, it's identified that the user is the one with, how do I explain this? But this public key thing abstracted is abstracted under the hood. Just like get that. Okay, so let's move ahead. Okay, so this is what I was trying to say, right? We have your, though I wouldn't, okay, so this is it. Account abstraction is Starknet improvement proposal 6 on Starknet. So we have three functions here. It has the execute, validate, and is valid transaction, is valid signature. That's what I was trying to say, that this is one of the functions that get called, right? This is the high level overview of the protocol, is valid signature. So when the signer invokes a transaction, this is, okay, you know what, let's come back to this. We'll come back to this. We'll come back to this. At this point, is there any question? Yes. Multi-call simply means a call that is done, that is supposed, okay, multi-call, 1, 2, 3 is done at once. Do you get? Is like you just join, it's either you just join the call or you are not following. I explained this, that there are some transactions that you want to perform that you, it will require you to sign a lot of transactions, right? But then on some chains, you will not be able to do this because it doesn't support account abstractions under the hood, right? So because of that, you'll be doing one transaction authentication one after the other. But with Starknet, right, you can have a multiple call at once. You can perform multiple operations at once. So I hope you get that. Mary. Okay. Please, one moment. Okay. So we are going to be talking about Starknet architecture now. Private. See, you don't have a business with private key. Actually, your account is a smart account. You don't have a business with private key. But one thing you need to know, that even on, like, you're signing a transaction, which means, how do I explain this? On your normal MetaMask, the reason why you're able to sign the transaction is because you have your private key, right? You have access to your private key, which is stored in the MetaMask, right? And then which dictates that the transaction is coming from the owner, only owner. Now, Starknet wallets are smart wallets, which means smart contracts, right? Then when you authorize transaction, you actually have no business with private key. Just forget about private key. I think that will solve it. Just forget about private key there. I'll send you a documentation that you go through for you to understand that in detail. Okay, so Starknet architecture sequencer, we're quickly going to go through this. Yes, so I made mention that sequencers are entities that pick up transaction, right? When when you sign transactions, right? They pick up the transaction, they process those transactions and aggregate those transactions. So sequencers are the entity that they act exactly similar to the way validators are on Ethereum. You know, validators are the ones that take up transaction in the mempool, right? Order those transactions and put them in blocks. This is exactly similar to what sequencer does on Starknet. They aggregate transactions that you make, they process transactions, they produce block. Currently, there's only one sequencer, which is at Starkware. At the moment, it's only one sequencer. Now, provers. Provers are the entity in charge of receiving these blocks that was produced by the sequencer. They process these blocks. They generate a proof that the transactions contained in these blocks are correct, right? And they send this proof to Ethereum for verification and layer one finality. There's a diagram that is going to make you understand this better. Yeah. So, why did I jump that? Question? Okay, ask your question, please. Please, I'm waiting for you, Chris. Okay, I think that was a mistake.
Okay. My, can you hear me?
I can hear you. Please go ahead.
Okay. You mean the sequencer pick the transaction from the mempool, then um like they process it, then pass it to the prover, or so just like confused over there.
Okay, so don't confuse yourself. After the sequencer takes these transactions, the sequencer, see, once you sign a transaction, it's being sent to the mempool. The mempool is where transactions are until it's being picked up and then put in a block. Now, sequencer aggregates these transactions, they process them, they produce blocks. Blocks are where transactions are being batched together inside. Now, the prover now receive those blocks, right? Process them and generate a proof for the correctness of the block, and then send the proof to Ethereum. Do you understand, or you do not still understand? Okay, please ask your question. Okay, thank you. So now we have nodes, just like we have nodes on the Ethereum chain here. There are entities that keep track of the latest states on Starknet. The way they do this is they replay transactions, they rely on L2. So there's actually no consensus mechanism on Starknet. You know that Starknet doesn't is dependent on Ethereum. So Starknet relies on Ethereum security, and you know Ethereum uses proof of stake security. So the yeah, so the consensus is still like there's no consensus mechanism. It's just like just like we have entities that you just have to like come into agreement, but there's no mechanism on Starknet. Now, nodes are also the ones checking proof validations on L1. I'm going to show you the smart contract that is responsible for verifying the proof on on Ethereum. Sorry. So now the node, for you to be able to run a node on Starknet, right? There's a setup. The setup has pros and cons. You have hardware requirements, trust assumptions, and latency. So if you're interested in being a node on Starknet, you can check out the specs just right here. So a full node on Starknet answers questions about the Starknet state, right? A full node can query the data or any data on Starknet, right? Users don't directly interact with the sequencer. Only full nodes do. So when we are talking about, I'm actually talking about that transactions are picked up by sequencer. It actually passes through the full node. Full nodes can see it, can communicate with the sequencer along the way. So it's equivalent to an execution client on Ethereum. So currently, Starknet has 4 different full nodes. We have Juno, maintained by Nethermind. It is written in Go. You can check it out. I attached the link for each. You can check them out. We have Pathfinder for maintained by the EQ Labs, written in Rust. We have Pyrus. We have by the Starkware team, written in Rust. We have Madara. It's a community. It's maintained by the community, also written in Rust. So full nodes expose an RPC server. You can check out the specs here if you're interested in full nodes. Just know that the nodes in on Starknet, just like on Ethereum or any other chain, they can query, especially full nodes, they can query the blockchain, the Starknet state, right? And then yeah. So Starknet modules. When you so let's use, okay, before we even go on, do you have any question before I explain the Starknet modules, or I should just go ahead? No question. Yes, Madara. You can check out the link. Madara is also a layer 3 on Starknet, but I'm not going to be going into that. You can go search it. The sequencer and provers activities are done in the mempool. No. Mempool is a place. So let me show you this. I have a slide. Okay. See the mempool. See the mempool. See how people queued here. That is exactly, it's just a place where transactions are sent. When, imagine all of us, I just made mention that it is only one sequencer that we have, and sequencers are the ones in charge of aggregating transactions, processing them. Imagine all of us here, let's say we are like a million. I'm just using a million because we are not as much, we are just 95 here. Let's say a million executes a transaction. This transaction is not going to get executed immediately. So those transactions were going to be kept in the mempool. This is where pending transactions, right, stays until it is being picked up by the sequencer and then being ordered in a block. When it's being ordered in a block, this prover accepts this block and then makes a proof, generates a proof for the block. So the main pool is not where the sequencer and the prover's activity are done. No. Okay, beautiful. Chris, do you have a question? Is the node like a position human run? Okay, is the node like a position human run? No. So there's actually, see, for every of these things that I'm making mention of, nodes, sequencers, all of this is not that they are not doing it for free. So even for you to be able to run something like that, you need like there's every requirement. You don't know how much is going to go into the cost of the requirements that is being required for you as a node provider. You can check out the specs attached to the link I sent, right? So I just actually said that if you are interested in becoming node, you can actually become a node provider on Starknet if you have the capacity to. You can check out the specs. Yeah. Okay, so back to, okay, now Starknet modules. So now we have your computer, which is you. You're the one handling your computer. You write your Cairo program. It compiles down. Once you compile your Cairo, the Cairo program gets compiled down to Sierra, right? Then this Sierra is being sent to the sequencer, right? Now, once it's being sent to the sequencer compiles the Sierra down to CASM, Cairo assembly, and then it runs in the Cairo VM, right? Now, a trace is being sent to the prover. The prover is Sharp. Sharp is full meaning of shared prover. Shared prover in the sense that it's being shared with, it's not only Starknet that is using it, StarkX is also using it, and other like the YDX and other permissioned blockchain on Starknet, right? So now, once the validity proof is being generated by the prover, is being sent to Ethereum, to the verifier smart contract. There's actually a verifier smart contract on Ethereum. Let me show you. This is it. Can you see this? Let me send you the. Please enter the. Oh, you'll get the link to the slides after the class. So as you can see, this is Etherscan, right? And then you can see Sharp verifier. It's a contract on Ethereum where the proof that is being generated by the Sharp prover is being sent to for verification, right? So once it's being sent, once it verifies it, now there is finality. But this is just like a oversimplified version. We are still going to like get into it in a bit. Now, Starknet, like I mentioned, uses smart contract. Yes. Before executing a smart contract, it must first be declared before it's being deployed. I will explain more about declaration and deployment when we get to transaction types. Now, users interact with Starknet via transactions, right? even not just on Starknet, on any chain, if you want to interact with on chain, you have to like, there has to be like a transaction. You're signing a transaction, right? That's like you interacting. You reading from a chain, that's not interaction, more like interaction in the sense of changing the global state, right? Now, and transaction must be signed when you're interacting via transactions. Now, when you want to declare a smart contract, so let me just explain the difference between declaring and okay, just hold on. This is how should I do it? Okay, let me explain declaring versus deploying, then I come back to that. So now, declaring it, when you write a smart contract, right, you don't just, that's one unique feature it also has compared to Solidity, where you just deploy your contract straight, right? But on Starknet, it doesn't work like that. There are two transactions, there are actually three transactions. Well, first you declare your smart contract. When you declare your smart contract, it registers the code on Starknet. There's no storage yet. So it's just like a blueprint. It's a registration of a blueprint on Starknet. And then when you declare your smart contract on Starknet, you get a class hash. So this is what I'm saying. There's a class hash that you get, contract class. There's a class hash you get when you declare your smart contract. Don't worry, all of these, they're just theory. When you get to the practical session, when you get like actual coding, you will recall everything that I'm saying and actually see everything in practice, right? So a declared transaction, a declared smart contract, SC smart contract. Declared smart contract is known as a contract class. So for every declared smart contract on Starknet, you get a class hash for it. You declaring a smart contract on Starknet, you're registering the smart contract. It's just like a blueprint with the code. The logic is there, but the storage is not yet there. Because you have a class hash now, you don't have an address yet until you deploy the smart contract. Now, a contract class is ID'd by its class hash. Contract classes are pure code, like I said, no storage. It's just your code. It's a blueprint, right? Now, to get a contract instance from the declared contract that you have, so the contract instance can be derived from the contract class. You now deploy the smart contract that you declared using the class hash. Now you can have the contract instance with its address, with this design, with this design, if let's say you want to deploy many contracts from this contract class, right? Once, because it's already declared, because it's already there, you don't have to like go through the process of declaring or something. You just like pass in the constructor that is I think for Solidity developers that will understand what I'm talking about here, and people that are very vast with OOP. Constructor, you pass in the constructor argument and then the class hash, and then you deploy the contract. You get the address. Please, it's not complicated. It's not complicated. I'm just like trying to explain like the benefits, right? And then Doing this also, the gas, once you declare your contract, the gas that would be enough for the execution is already calculated. It's already pre-calculated, right? So that's that. So a contract instance has storage. So a contract class on its own doesn't have storage. When you declare it, there is no storage. It's just pure code until it's been deployed. Now, there's storage. It has storage. A contract instance is ID'd by its address. You know, I mentioned that a contract that is being declared, which is a contract class, is ID'd by its class hash, while a contract instance that is being deployed is ID'd by its address. Now, let me come back. Okay. Now, declaring a smart contract. After you have written your smart contract in Cairo, you want to declare the smart contract. This is your laptop. This is your Cairo smart contract, right? It compiles to Sierra. Now, once it compiles to Sierra, you create a transaction. You create a transaction in your wallet, right, to declare the transaction. So one of declaring a smart contract is one type of transaction on Starknet. So you declare a transaction, you still authorize using your wallet, right? You declare the transaction. So the Sierra code that's been compiled down here is sent to the sequence, is sent to the mempool. Sorry, this is the mempool. And then once the Sierra code is being picked up by the sequencer, it compiles down to Cairo assembly. And then what happens here, right? The sharp is supposed to generate a proof for it, right? Now, the question of what to be sent to the prover arises, right? You know, now I said the Sierra code is sent to the mempool, picked up by the sequencer, is compiled down to Cairo assembly. Now, the question of, okay, what trace is to be sent to the prover arises. Can we send the proof of the compilation of the smart contract? But that's not the case. In order to do that, the compiler has to be written in Cairo. Currently, the compiler of Cairo is not written in Cairo yet. Right? Now, we'll come back to this. This is proving compilation. So the Cairo compiler is currently written in Rust. And with Rust, you know, I mentioned that Rust is not a provable programming language. Compilation can't be proven in Rust. The long-term solution is to write the Cairo compiler in Cairo, and then compilation can be proven. So the stopgap solution as to what to send to the prover here is we need to provide the CASM hash while declaring. You know that the whole essence of the Cairo is to be able to prove executions, your computations, without having you to re-execute the computations, right, to compare results, right? So now, because the Cairo compiler as at this time is not written in Cairo, what we have to do at this point is provide the CASM hash while declaring. So whenever you're declaring, whenever the declare transaction is being done, the CASM hash is provided. Now we let the sequencer recompile Sierra, and then once it recompiles Sierra, it now checks it with the CASM hash that was generated, compiles the hashes. So do we understand, or I feel like you guys are a bit confused? Do we
If you are
understand?
if you are confused, please, I want you to speak up. Or if you understand, I want you to explain what she explained in the way you understand it. Right? I think we can do that.
Yeah.
So if you understand, explain. If you don't understand, ask question. Probably you can
Okay.
pick one of 3 people, Sarah, so they can try to explain it.
Yes, yes. Okay. So guys, if you actually understand what I'm trying to say, from explaining Cairo as a provable programming language, there's a lot of information. The reason why that is because this is not the practical session yet. That is why. But then there's still, you need to learn basics. You need to learn basics. So you'll not just be like other developers that just go into the code. You just want to code. You just want to like deploy contracts. No, you need to like understand some basics. Hmm, let's just go over it a little. But I won't. I will just like do a summary. Yes. So when it comes out to, we don't actually have much time left, and we still have a lot to cover. Okay. So what happens is, mm, hold on. So I explained, you understand Cairo, that Cairo is a provable programming language, right? And that you don't have to, yes, as at this point. So I think where you guys are confused is where I mentioned that Cairo syntax was inspired by Rust, but they are different, right? Cairo runs in the Cairo VM, while Rust runs in the CPU architecture of your computer. They are different. The Cairo syntax is just inspired, and then it takes a lot of we call it borrowing from Rust, but they are different. At the moment, Cairo compiler is written in Rust. Do you want to know how to build a compiler? So that's why you don't really have to like think it's like too deep. So the Cairo compiler, yes, divine, it's written in Rust at the moment, but it's not provable. So in the future, I'm sure the Starkware team are going to work towards making the Cairo compiler, writing it in Cairo itself, right? So the difference between declaring, wait, before I get into the difference between, let me finish this first. So um 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 because the Cairo compiler at the moment is not written in Rust, right? When your Cairo smart contract gets compiled to Sierra, you sign transactions to declare your smart contract. The Sierra code is being sent to the Mempool, right? And then the sequencer is the one responsible for compiling that is being sent to the Mempool to Cairo assembly. this is where the problem now comes from, because as at this moment, Cairo compiler is not written in Cairo, it is written in Rust. At the moment, it is not provable. So, which is why when you want to declare, right, the store gap solution before the Cairo compiler will be written in Cairo itself is to provide the CASM hash while declaring. You see, when you're writing your smart contract, the first time you write your smart contract, when you deploy your when you compile the smart contract, there's a class hash that will be generated. So which is what you will use to declare, you will use to attach to declare your smart contract. So now declaring that transaction with the class hash, what the sequencer will now do is just to recompile this Sierra code that was sent. So once it recompiles it, it also generates a CASM hash. Now, it will not compare the CASM hash that it just recompiles to with the CASM hash that was sent with the declaration transaction. And if they are correct, right, then it can be sent. If they are valid, it can be sent to, then it can be proved. The validity proof can be generated, and then the verification on Ethereum will occur. So do you guys understand it to this point? So for the person that was asking the difference between declaring and deploying, declaring is registering your code on chain. It is just your code, you are registering it. It doesn't have any storage on chain, it doesn't have address yet. So, but when you deploy the declared smart contracts, then you will have the storage and you can start interacting with it on chain. You have the address. This is just like the way it happens on Starknet. You have to declare your transaction first. Your registering is just like you registering a blueprint of your code on Starknet, right? And then when you want to deploy, the class hash that you get, the Cairo VM is already familiar with it, right? It already verifies it, and then you just deploy, and then you get your address. So that's how it happens. You see, when it comes to this declaring and deploying, don't worry. I think it should be in week 3 or so. Week 3, you guys are going to like see this in like practical. So it's not like booking a storage slot. I'm not going to take it like that. It's just you know, how do I want to explain this in the real sense? So let me do this. So let's say you want to go to a school. You have just registered on site. You have just registered your name and your things, but you are not paid. You are not paid yet. It's just like your information is there, but it can't do anything yet. Do you get? I don't know if you understand. When you're declaring your transaction, you're just registering you're just registering the code logic on Starknet. Don't worry, let's not take this thing too deep. Yeah, you get it. Yes, you get it. Don't worry, when you get to week 3, you understand everything, and at that time you have become bosses. So now, sending the CASM hash. Now, we have the laptop. This is same as before. Your Cairo smart contract It gets compiled down to Sierra, compiled down to CASM, create transaction in your wallet, declare transactions. Now, the Sierra code, CASM hash, the sequencer compares it to CASM. What am I saying? Sorry. Okay. Yeah. So from here, the whole architecture that is happening has changed. It is now like this. You know, previously we had the Cairo contract, Sierra wallet sends to the main pool. Now we have the Cairo smart contract gets compiled down to Sierra, gets compiled down to CASM. You create a transaction to declare your contract with your wallet. With now the CASM hash is sent together with the Sierra code, right, to the main pool, right? The sequencer now picks it up, compiles it, and then sees that okay, the CASM hash actually matches. If it doesn't match, it's going to get ignored or fail. So that's what happens. Is there any question at this point before we explain? Okay, I already explained declaring versus deploying. Is there any question at this point? No question. So universal deployer. Universal deployer is a smart contract on Starknet that deploys other smart contracts. It's just like a public good. It's a smart contract. If you're a Solidity developer here, you should be familiar with factory contract, that you don't need to especially an example is the ERC20 token. A lot of people create tokens. You wake up today, you see dogs and banana, this, that one. So instead of you deploying all these contracts, writing them from scratch, you have a universal deployer that what you just need is to provide the constructor argument for that particular token you want to deploy, and then it gets deployed, and then you get the address. So that's like what universal deployer does. So there's only one selector in the universal deployer, which is deploy contract. The selector must be invoked with the blueprint contract class, contract hash, and the constructor argument. So you can check out Open Zeppelin has universal deployer. I think it's the only universal deployer written in Cairo. It's not even normal Cairo, it's still written in Cairo 0, but the Cairo 1 version is still in production. So but at the moment Open Zeppelin has it written in Cairo 0. Is there any question at this point? Eh, 10:20. Wow. Transaction lifecycle. Okay. So the way transaction happens is you either perform transaction, a normal transaction, if not a smart contract, if you're not deploying a DApp, you either perform it with your wallet or your system, right? Now, please follow along. This is your wallet, which is your maybe your Agent mobile. You sign a transaction. The transaction is being sent to the main pool. So once the sequencer gets checks this main pool, see your transaction, it checks if the transaction structure is correct. If it's correct, it checks again if the um the transaction is valid, the transaction signature is valid. Then if it checks the transaction signature is valid, then it runs in the Cairo VM. Now it's in the Cairo VM that it now checks that okay, the transaction that you sent, is it sent with enough gas? If it's not sent with enough gas, it fail, right? But if not, if it doesn't fail, right, it traces, it sends a trace to the prover. Now, from here, all this sequencer talk that I'm talking here is happening on layer 2, it's happening on Starknet, right? So once it gets on the sequencer in the mempool, right, the transaction status, it changes to received. So if the transaction structure is not correct, or the signature, if this transaction structure is not correct, it's ignored, right? So now if the signature this signature validation is also not correct, so it's either remain unchanged, sorry, it gets rejected. But if it's correct, it gets unchanged, and then it changes the status to accepted on layer 2. But if the transaction doesn't have enough gas, it is reverted, so it won't be accepted on layer 2, not to talk of even being sent to the sharp. So let me show you the transaction. Let's check stack scan. Let me see, would we be able to cover? Hi. Oh my god, I was thinking I was going to be able to cover everything. Oh, so not time. Okay. Stack scan. We have, why is this still loading? Okay, so let's view transaction. I want you to see what I'm trying to say. So now you can see one status here, accepted on layer 2, accepted on layer 2. This is being reverted. Is either probably the gas wasn't enough, or let me see at which point does it get reverted. Yes, the gas wasn't enough, or it failed assertion. Let's say maybe when it gets to maybe the compilation that you're trying to do, 1 plus 1 is giving 3, right? Or 2 plus 2 is giving 5. So that failed assertion, so it's going to get rejected. So it's either the guess is not enough, or the assertion fails. So that's where it gets reverted in the Cairo VM. Now, once it's accepted on layer 2, a trace is being sent to the sharp prover, and then the sharp prover generates a validity proof for these transactions, and then sends it to the verifier smart contract on Ethereum. So once it is sent to this verifier smart contract on Ethereum, it's now accepted on layer 1. So to see any transaction that is accepted on layer 1, let's see. It's going to be down. 19 minutes ago. I need a transaction that is 10 hours ago. So the problem is that finality on Ethereum happens every 10 hours. Every 10 hours. That's why you're not seeing accepted on layer 1 yet. Is there a way? Let me check if there's a way that I can order this. Okay, let's check. Sorry, hold on. I just want to show you that part. of accepted on layer 1. Do you have question? Please, you can unmute your mic and speak. I don't know who's asking question, but okay, you can see it now. Accepted on layer 1, accepted on layer 1. So this is when there's finality on layer 1. So who is asking question? Okay, thank you. Okay, so we move to transaction types. We have declare transaction, invoke, and deploy account. Those are the 3 transaction types that we have on Starknet. You can see it here. Hold on. We have to scan Explorer on Starknet. We have StarkScan, and then we have Voyager. And the 2 dots same thing. Just want to show you something. Okay. This is pending. It hasn't been picked up yet by the sequencer. So you can see the transaction type, invoke. Where is it? I'm trying to check something. Okay, so this is what we have: declare, deploy account, invoke. So declare, like I said, it registers new code on Starknet. Invoke, it executes write functions. You see that function that is changing global states, apart from deploy account. Those functions are invoke functions. You're invoking, you are writing transactions. Write functions are invoke transactions on Starknet. Deploy account transactions, it deploys an account contract, a smart wallet. So all these transactions modify the global state. Hence, you pay gas fees for these transactions. Calling a read-only function is not a transaction, as it doesn't modify the global state. No gas fees is paid. When you call a view function in your Solidity smart contract, it's just a view function. You're not making any changes to the global state. You're not writing, you're just viewing, you're reading from the state. You don't pay gas fees for it. But when you're writing, there are fees that is being paid. When you're writing, say you want to deploy your contract, you will pay. If you want to write to your smart contract, you want to trade token, you will pay gas fees. So that is it. So transaction finality, I want to quickly, so next, I'll just go through this. So layer 1 finality, on the layer 1 finality on Ethereum is 6 minutes. So let's check it. Etherscan. Are you guys still following me? Or you're sleeping? Okay. Oh no. This is not what I'm even checking. Thank you. So if you check transactions on um, hmm, transactions on, okay, we have, hey, where is the block? Oh, 19-second block. Okay, block. Yeah, this is, let's come back to. So, finality on um on Starknet. Please just listen. Standard finality on layer 2 on Starknet takes 2 seconds. Once you send your transaction in 2 seconds, you will see either is accepted on layer 2 or is reverted. But you see, when you want to get finality on Ethereum, it takes 10 hours to get finality on Ethereum. So let me show you what I mean by 10 hours. This is the sharp verifier on Starknet, on Ethereum, sorry. So as you can see, if you see the difference in hours, you will see 17 hours, 27 hours, 37 hours, and so like that. There is 10 hours that it takes 10 hours. For roll-ups like optimistic roll-up takes 1 week to get finality on Ethereum. So you can see the difference. Starknet's own finality on Ethereum takes 10 hours, while layer 2 finality on Starknet takes 2 seconds. So I already explained Mempool. Can I still explain? No, time has gone. Sorry, hold on. Okay, let me just sharply run through this. So now we have the pending block. We saw the pending block just here. Okay, so can you see? We have this pending block. Now, the pending block are transactions where those are the places. Who is that? Mr. Oluwafemi, please. Let's quickly finish this up. The pending block is the main pool, right? Where, sorry, what am I saying? It's not the main pool. So the pending block are where transactions are being sent to, transactions that are being created by sequencers are sent to, and then transaction get added to the pending block. We have finality, layer 2 finality in 2 seconds. Transaction gets executed, that is accepted on layer 2. So this block is still pending because it doesn't have the threshold yet, the threshold of transactions yet. Now the same process repeats until the block status changes to created. Now, there's a particular limit to what a block can contain, the number of transactions a block can contain. Now, the max size used to be 40 million Cairo steps, but now it's 45 million Cairo steps. Cairo steps are just computation, right? So, and then for each transaction that added in a block, the maximum size it can have is 10 million Cairo steps. It could be this much because some transactions are very complex transactions, right, that involves a lot of Cairo steps. So per transaction, the highest maximum size a transaction can have is 10 million Cairo steps, while the maximum size a block can hold, the maximum transaction a block can hold is 45 million Cairo steps, which is done in 30 seconds. So once 30 seconds reach, this block is being created. So either 45 million Cairo steps is reached or 60 seconds is reached. So that is how blocks is created. Now, event timeline, we are going to be finishing now. Sequencer receives transactions, right? Once it receives transactions, I already made mention of this actually. So it's just the time, it's just the event timeline that happens across when the sequencer receives the transaction to when it's being finalized on Ethereum. Now, when the sequencer receives the transaction is being executed in 2 seconds. So in 2 seconds, from the 2 seconds, in 30 seconds, the block is being created. The transaction which was sent with other transaction is being created in a block. And then in 10 hours, the validity proof is verified on layer 1, which is layer 1 finality, and that is all. So the summary of transaction finality, we have transactions are executed in the order they arrive. That's FIFO, like it happens in Stark, first in, first out. There is nothing like front running or you want to increase your gas fee so that your transaction will be executed faster. Nothing like that on Starknet. New transaction, when the transactions arrive, it is being added to the pending block. Transactions are executed right away. Layer 2 finality, that is on Starknet. In 2 seconds, your transaction is being executed. Layer 2 finality happens before block is finalized, right? A new block is created every 30 seconds. A block can hold up to 45 million Cairo steps, and a transaction can hold up to 10 million Cairo steps. So, yeah, this is the end of this part. So, I don't know how my schedule is going to be on Friday. We are going to go through Cairo syntax overview in 1 hour or less. We should be done. Cairo syntax overview, and then setting up dev environment. I don't want to take much of our time. Time has gone. Is there any question? Do you have any question at this point? Question? Can you guys hear me? Or you guys are too? Yeah,
If you
too
don't have
brilliant.
question, if you don't have question, we'll ask you. You ask you guys questions. So better ask questions.
Yes, sir. This is a mistake.
I think one person raised hand.
Okay, please ask your question. I'm actually going to be asking a couple of questions now. Okay, can I shoot? Please, is the transaction like sending of money? What transaction do you mean by sending of money? Okay, do you mean like normal transaction? Sending of funds is an invoked transaction. Yes, is a transaction. If that is what you're asking. Can you send all the slides so that we can read? Okay. Yes, you don't actually have much to read. We just we're going to be doing setting up dev environment, and I'm just going to be doing like a Cairo syntax overview. It's not like I'm going to be explaining in detail, just you know that time has gone. And or should we continue? I'm going to send it. I'm going to send it. Okay, so I have some questions. Mm. So, hey, okay. So what does it mean when a transaction has a status accepted on layer 2? What does it mean when a transaction has a status accepted on layer 2? That should be like very simple for you to answer. Who is going? Oh yeah, Apolabi. I'm waiting for you. The transaction is being approved. Approved where? Approved how? You know, now when we are talking about this thing, now it has to do with L1 and L2. Now,
No.
when a transaction has a status accepted on layer 2, what does it mean?
So it means that the gas is enough for it. That is in from the Cairo VM.
Okay, the gas is enough and the assertion did not fail. That is
Yes.
correct. Yes, so that means the transaction was successfully executed. So once the transaction is successfully executed by the sequencer using the Cairo VM, when it's successfully executed by the the sequencer by the Cairo VM, means that the class is enough and there is no assertion failure. So that's very brilliant. Thank you. What is a universal deployer? Who is going? A universal deployer. Ah, is it only Mubarak that is learning? Please, oh, other people. Chris, what is a universal deployer? Don't go and check this thing. Oh. I want to actually know that you guys followed and you understood what I we taught today. Okay, Prosper.
Okay, a universal deployer is a smart contract that deploys other smart contracts.
Beautiful, beautiful. Yeah, thank you. That's correct. Someone says like factory contract is solidity, but I don't want you to use solidity. Just tell me that is a contract that deploys other smart contract. That's correct. So which other questions do I have? How long does it take for finality to happen on layer 1?
10 hours.
You're coming down. I did not call you. Let's who is 2 seconds? No, that is wrong, Emmanuel. So the finality on layer 2 is 2 seconds, but the finality on layer 1 takes 10 hours. Right? Don't confuse, don't mix things up. Finality on L2 takes 2 seconds. Finality on L2, that is Starknet, takes 2 seconds, while the one on Ethereum takes 10 hours. Awesome. What's a pending block? Oh yeah, Chris, I want to hear your voice talk.
Okay, a pending block is a mempool. Is
No. Okay, so I'm going to give you, let me give you options. Okay, a pending block, I'm going to give you just 3 options. A block that is no longer receiving transactions. That's A. A block waiting to be added to a validity proof. A block that is still receiving transactions.
yeah, I think the answer is B. B.
Eh? B.
The answer is
That
B. Yeah, B.
B. A
Waiting
block
to be added to
waiting
the valid. Yeah.
to be added to the validity proof. Uh, who is there? Okay, David, what do you think?
I think it's a block that is still receiving transactions since it has not yet hit the maximum limit. I don't
Okay,
remember the exact number.
awesome. So, Chris, a pending block is actually a block. It's not, once a block is still receiving transactions. First, it is not a mempool. A mempool is a place where transaction is being sent to. First, understand it. When all of you in this class, you execute a transaction at once, the transaction is being sent to the mempool first. When it's being sent to a mempool, it is not in a block yet. It is when a sequencer picks up your transaction, right, and process your transaction, then add it to a block. That is when a block is pending. And when a block is pending is as transaction is being added to the block is still receiving transaction. It is not being created yet. It has not reached the maximum size required, which is 45. Was it, yeah, is it 40 or 45? I forgot. Let me check. Let me just confirm. Either 45 or 40. No, I think it's 45. It used to be 40 before. Now it's 45. Yes, 45 million Cairo steps. So then when the block is now created, it is when the block is now created that a validity proof is after the block is being created that a validity proof is generated and then sent to Ethereum. Do you understand now, Chris? Or should I go by it again? Chris, I want to know you understand it before we close this call today. Okay.
Yes, understood.
Awesome. Uchenna, do you have a question or do you want to answer a question? Don't worry. I have one more question. What is the full meaning of sharp? This is where even if I share the slides, the answer is not there. But I've been mentioning scholar share prover. Yes, that's correct. That's correct. So one last question. When Cairo program is being compiled, what is it being compiled to? Sierra. Yes. Yeah. And why is it being compiled to Sierra? What is the reason for that introduction of Sierra? You know, I explained that there was a problem initially with Cairo. Okay, David, explain.
Why it's being converted to Syria is because of failed transactions were not written to the blockchain initially. So Syria was created to solve that particular problem.
Awesome. I'm so proud you guys are actually following. That's beautiful. That's beautiful. Okay, last question, I promise. So when we talked about declaring transaction, and then we talked about declaring a smart contract and deploying a smart contract. When you deploy a smart contract, there's an ID that is being given. Then when you deploy a smart contract, there's also an ID that is being given. What are these IDs? Who is going? Okay, awesome. Uchechukwu, please answer that.
Class hash.
Okay, and that is for declaring transaction. For deployment, what is the ID that is being generated?
I don't know that one.
When you deploy your transaction, okay, who knows? Address. Awesome. Yes, it's an address. You get an address when you deploy a smart contract. Okay, so I don't want to we just have this we can't actually finish this night, honestly, because you have to set up the dev environment, and also we're going to stop here tonight. So I'm going to communicate with Kelvin, because honestly Okay, I'm just going to communicate with Kelvin. So see you hopefully on Friday. And yeah, thank you for listening. Hope there's no questions. Uchenna, do you have question for me?
No question.
Awesome, awesome, awesome. Let's appreciate Sarah for the amazing session tonight. I mean, it's been an amazing one. Let's appreciate Sarah for the great work. So yeah, like you said, or like I mentioned at the onboarding call on Monday, we may not be able to cover everything in 2 days, and that's why we made provision for the third day of the week, which is Friday. Friday is meant to be assignment and test. That is if what was supposed to be taught in the week was covered in 2 days. But if not, that means the next class is going to be on that Friday. So it's usually like the finalizing of what is to be done for the week, and you know, then you'll be given the assignment or test for the week. So the next class is going to be on Friday. Yeah, same time, 8:30 p.m. Same link. The one is in that is in your Gmail that you use to attend this class. That's the same link you're going to be using every day for all the entire 8 weeks. So yes, join us on Friday, um, 8:30 p.m. West African time, so you don't miss out. So yes, for all she has taught today, the slides will be sent on the group. A lot of people kept complaining about internet connectivity today. So if you're among those people, please prepare yourself well for class next time. Okay, prepare yourself well next time for class. So you have to check your network before class. You know, let me type the link to the slides on the group.
Yeah, and I also shared the document, the Starknet book. You can go through the architecture. It has all of the things.
Also, so I've also shared that on the WhatsApp group. So you have the Starknet book, which explains more on these things that she summarized or taught you guys in tonight's class. So you can go through her slide, go through the Starknet book. These are the resources you have to read. Remember, you don't learn solo. Resources are very, very important. So you can't learn everything in the class. All right. Personal reading and personal study is very, very essential for you to actually go far. So go through our slides and go through the Starknet book. Read as much as you can. Understand about the validators, by the prover, everything. Right? Personal study is one that's going to help you to become much better. So, like mentioned, next class is Friday, 8:30 p.m. So if you have not, take a screenshot of yourself in the call. Very important. Like we mentioned, everybody should ensure they are posting about this bootcamp on Twitter, on LinkedIn, on Facebook, whatever social you use, but we prefer Twitter. All right. So any social user, make a post about this class, tag GIDA, tag the instructor, Sarah Oluwatosin. You can drop a Twitter handle so they can tag you. So tag Sarah, mention what you learned. You know, the best way to actually grow is by building in public, like I always say. So make sure you are actively building in public. So any class you have, make a post about it the day or the next day, so that it will also help you to be accountable to yourself, and others can also know that you are actively taking on a new task. So Sarah has dropped her Twitter handle. So you make a post, tag her, thank her for teaching, thank GIDA for bringing the opportunity to you. You can even tag my handle. Mine is I'm gonna type that for you. At Kevin underscore Chiboyim. So that's my Twitter handle. So you can tag all this and be detailed in your posts, because you're pouring out what you know. So you can reference them in 1 or 2 or 3 years time when you are a badass Starknet or Cairo developer. So yes, Sarah, any final words before we wrap up? Friday session, I hope all is in order.
Okay. Majorly, Friday session, just come with your PC. Like I said, this class, I thought we were going to be able to cover this. And then it seems a lot of people here already have it Rust installed, right? Which is beautiful. If you haven't installed that, I'm going to be sending a link. Though we're still going to be going through to confirm on the call on Friday. But that's just that. Just come prepared, come with your PC. And if you have any question from the previous class, you can also come with the question. And then I also be giving you asking you some kind of questions as well. So, yeah, just come prepared. Yeah, it might not last more than 1 hour, but trust me, the 1 hour will be worth it. All right. Thank you and have a restful night.
Awesome. Perfect. Perfect. So, like you mentioned, Friday is the day. Come with your laptop. So, if you're having network issues today, make sure that day you don't have network issues. We're going to go really technical. The recording of tonight's class is going to be posted on the YouTube channel tomorrow. If you're not yet subscribed on the YouTube channel, please do well to do that. Just go to YouTube app and search, official GIDA or search Ginakev Digital Academy, and you're going to find it. However, I've dropped the link to the YouTube channel right now on the chat. So if you're not yet subscribed, subscribe and turn on notifications. A lot of people didn't know that the recording was posted yesterday, right? So subscribe and turn on notifications so you'll be notified once there's a video posted on the channel. So yeah, this is where we'll call it a wrap for the night. Do have a good night rest and see you soon. For those of you that will be in Web3 Lagos, we'll be seeing each other there. We're also going to be providing some exclusive GIDA merch for attendees. So if you're in Lagos, in the Southwest, or coming from anywhere, Lagos. So we have a WhatsApp group for people that are attending Web3 Lagos. So you can update when GIDAs are meeting for a group photo and when merch is being distributed. So I've dropped the link in the chat. So if you are based in Lagos or attending the Web3 Lagos conference from anywhere, it's a 3 days conference starting from tomorrow down to the other day. GIDA is a community and hackathon partner. So see you there. I will be there personally. I'll be coming into Lagos. I'll be flying into Lagos tomorrow. But I'll be speaking at the event on Saturday. So if you plan to just attend only on one day, Saturday is actually a very good day to attend. So yes, have a good night rest and see you soon. Friday, don't forget your class on Friday and make the social post this night. Good night. Bye-bye.